Okay, so chapter 2.1 is basically about describing locations of data. One way we can do that is percentiles, and I did a video on that earlier, and now we're going to go over the second way to do this, which is describing the standard, the z-score, basically the standardized score. So that's another way of describing the location of a data point. And so we're going to use this problem. Again, all these problems are from the Practice of Statistics, the updated edition, and I'll have that linked below the book, okay? So where does Emily's 43 marked in red? So it's actually not marked in red. Let me see. Should be this one right here. So let me bold that. Okay. So where does Emily's 43 fall in the distribution? Her standardized score is, z-score is, z is equal to value minus the mean over the standard deviation. So her value is a 43, so that's how much she earned. That's her score. We subtract the mean from it, and then we divide by the standard deviation, and we're getting that data from here. And we're getting that data from this table right over here. And we have this value 0.86. Now, what does this value mean? Well, that is her z-score. That is basically saying, okay, Emily's test score is 0.86 standard deviations above the mean score of the data. Okay? Of the class, excuse me. Okay, so now let's try this example. Ready? So find and interpret the z-score for Jacob, who earned an 18 on the test. So if we go back up here, we would say that this is our this is our 18. Okay, so this is our 18, and that was Jacob's score. And we're supposed to interpret the z-score for Jacob. So the way we do this, we have an equation right here. So let's use this equation. So we're gonna have z is equal to the value is what, 18, minus the mean, which if we look over here, the mean is x bar 35.44. And then divide by the standard deviation, which is s sub x, so 8.77. And when we put that into the calculator, we are going to get the answer of negative 1.9888597, and it keeps going. But for z-scores, we're going to round it two numbers, so we're going to say negative 1.99. So that is the z-score for Jacob. So we can say that Jacob's test score is 1.99 standard deviations below the mean score of the class. Another way, below the average score of the class. So it's basically telling you where his score would be located in. So that's one way, okay? And then let's do part B. So Tamika had a standardized score of 0.292. Find Tamika's test score. Okay, so let's do this. So if Tamika had a standardized score, okay, so we know the equation. So we know z is equal to value minus mean. It's good to keep rewriting it so you memorize it. Standard deviation, okay? So we already know that z is 0.292. We want to figure out the value, so we're going to have that as x because that's what we want to figure out. The mean stays the same, 35.44, and then the standard deviation also stays the same, okay? And now we just do basic arithmetic, and we, multiply, cancel this out by multiplying it up here, 77, okay? And let's see. So that should give us, let me actually fold it here. Okay. It should give us, when we do arithmetic, x is equal to 38, okay? So what does this mean? This means that Tamika's score was 38, okay? So we can use the z-score equation to get the z-score, and if we know the z-score, we can use the equation to work backwards and find the actual score that the student had in this case, right, in this context, okay? So that was part B, and you can see the solution here as well.